Good morning. Today we are going to continue with the derivatives of hyperbolic functions. We were on exercise 1.4. We're just going to do a few more questions there and then move on to the derivatives of the inverse hyperbolic functions. So we stopped at number 8. Next one is number 10. We have y is equal to e to the power of sine x, hyperbolic sine of x, and we have to work out the derivative. This one, we know how to differentiate it. We're differentiating e. The derivative is that function as it is multiplied by the derivative of the exponent. And for the derivative of the exponent, we have to use the product rule. So we have y prime. This is e to the power of sine x, hyperbolic sine of x. And then the product rule for the exponent, we have cos x, hyperbolic sine of x, and then sine x multiplied by the derivative of hyperbolic sine is hyperbolic cos of x. Okay, so there isn't really much you can do. You can multiply out the brackets, but leaving it like that is also fine because you can't simplify it any further. And 12, we have y is equal to, yeah.
You can go back to the previous page. I just want to copy something. Thank you.
And then tan of the hyperbolic tan of x. Okay, so this one by now we should know that logarithmic differentiation is probably the way to go. So we take logarithms on both sides. So we have ln of y is equal to x, ln of x plus ln of hyperbolic tan of x. And then we differentiate this. Here there's implicit differentiation. Over here, product rule, and then this is just a logarithmic differentiation. So we have y prime over y. This is ln of x plus 1. 1 over hyperbolic tan of x, and then we multiply by the derivative of hyperbolic tan of x, which is that. Okay, simplifying as far as possible and making y prime the subject. We have y prime. This is y, say 1 plus ln of x okay, and we can always substitute our y with that if our y is not very long. So we have x to the power of x, have 10 like that. And number 14, we have y is equal to ln hyperbolic cos of 2 square root of x. And this one, pretty simple to differentiate. Y prime, 1 over hyperbolic cos of 2 square root of x. Derivative of hyperbolic cos, hyperbolic sine. Derivative of 2 square root of x is just 1 over the square root of x. Okay, then you can rewrite this as a single fraction, but here we have sine over cos, that's tan. So we have hyperbolic tan of 2 square root x over the square root of x. Okay, the last one, number 16.
Question on the previous one.
Johannes?
Yes.
I can't hear what you're saying.
I'm saying I have a question on the previous one.
What is your question?
Isn't it supposed to end with the square root x multiplying 10? Because if we like break it up, won't it be like square root x times sine sine h2 square root x over cos h2 square root x? Won't it be like that?
Can you say that again?
What I'm saying, asking is, isn't the square root x multiplying with 10 to 10h to square root x?
Are they not? Here I have this times that.
Yes.
So when you say are they not multiplying, what do you mean?
What I mean is, isn't it gonna be square root x than h?
How do you get square root of x in the numerator?
Oh, I see. I made a mistake.
Okay, number 16, we have y is equal to that squared x over sine of 2x. So this one, we can just use the quotient rule to differentiate it. You could also try rewriting this. We know that hyperbolic cos squared is 1 plus hyperbolic sine squared, and then you can break it up. So you'll have, I don't know if that will be easier, but there's ways you can play around with it so that if you feel that is easier. Anyway, so we're going to use the quotient rule. So we know that y prime, this is the denominator the way it is. Then the derivative of the numerator Then we subtract the derivative of the denominator. Derivative is cos here, and then multiplied by the numerator as it is. Okay, so this is all over the denominator squared. Okay. Okay, let's just see numerator. Okay, we have the denominator as it is, derivative of the denominator, and then the numerator as it is times the derivative of the denominator. Okay, and then we simplify or continue, see how far we can simplify this. This is 2 2x cos and 2 and this is all over hyperbolic sine of 2x. Okay, if there's anything that can cancel, you can cancel that out, but it doesn't look like there's anything that we can cancel out that will make it look easier or better.
What if
Yeah.
you write? What if you write 2 cos hx sine hx as sine h 2x, and then multiply, then get sine squared 2x.
You can change this sine hyperbolic of 2x, then you end up with a sine squared, cos squared, and then the 4 there. You can do that, but I don't know if that is that much better than what we have already.
Ma'am, you're not understanding me. I'm saying the previous step where you have in brackets 2 cos hx times sine hx. Is that not an identity?
Oh, you can do
is
that.
the
There's
same.
nothing wrong with that. I think maybe you didn't hear me say there's always ways you can simplify. Okay, so this is not the only way that it can look. You can simplify it. So use the identities that you have. Okay, then we move on to the derivatives of inverse hyperbolic functions. The derivatives of inverse Right, so we've differentiated the hyperbolic functions. Now we're interested in differentiating the inverses of these functions. So just like we did the inverse trigonometric functions, the idea of how we work these ones out is pretty much the same. So we know that if we have y is equal to the hyperbolic sine inverse of x, this means that this is equal to x. So differentiating this we can do because we know how to differentiate this one. And doing that, we can differentiate sine hyperbolic, that is hyperbolic cos of y, and we multiply by y prime. This is equal to 1. So y prime, this is equal to 1 over cos of y. Then you need to keep in mind that we have this identity. This is one of the identities that we proved. So from this identity over here, we have that the hyperbolic cos is the square root of 1 plus, like that. So you make cos hyperbolic the subject of the formula, and then we can substitute this with that over there. So doing that, we have y prime. This is 1 over the square root of 1 plus hyperbolic sine squared of y. But we want our derivative to be in terms of x and not in terms of y. So we replace this y with what it was defined as in the question originally. So this is 1 over 1 plus the sine hyperbolic of sine hyperbolic inverse of x, and this is all squared. Okay, so sine hyperbolic of y, but y is sine hyperbolic inverse of x, and then you square it. So we know that the hyperbolic sine inverse will cancel. I'll be left with x. So this will just leave me with 1 over the square root of 1 plus x squared. Okay, and this, yeah.
I don't understand from the red pen there.
From the what?
From the red pen.
From here.
Yeah.
This is an identity. We covered it a long time ago. You should know it.
Yeah, I know this. That is an identity.
Yeah.
But why did you write it here?
Because I'm using it here.
This one is basically looking at you.
Can you switch off the TV in the background?
Okay, it's fine.
Okay, so first, like I was saying, this one, if you remember, the derivative of sine inverse was 1 over 1 the square root of 1 minus x squared. So you can see that the only difference between this one and sine inverse is the sign over here. Now, if you remember, we said that the hyperbolic sine inverse of x, you can also write it in terms of ln. So you can also, if you have y is equal to hyperbolic sine inverse of x, you can also write it as ln of x plus the square root of x squared plus 1. Okay, and you can differentiate this, so we can see everything is in terms of x. We know how to differentiate this without any problems. So just go ahead and differentiate and see that we will get the same answer. So y prime, this is 1 over x plus the square root of x squared plus 1. And then we multiply by the derivative of the bracket. So in the bracket, I have 1 plus, I have a half x squared plus 1. Let me just make some space. A half x squared plus 1 to the power minus half times 2x. Okay, so that is the derivative of the bracket. So I can simplify this first. So this is 1 over x square root of x squared plus 1, multiplying this with 1 plus x over the square root of x squared plus 1. Okay, then before I multiply, I can combine these two fractions. So this is 1 over x plus the square root of x squared plus 1 times square root of x squared plus 1 plus x. In fact, I don't even need the brackets anymore. Divided by the square root of x squared plus 1. And then this will just give me 1 over the square root of x squared plus 1, which is the same as what we got over here. 1 over the square root of 1 plus x squared. Okay, so you can see that whether you work out the derivative using implicit differentiation, that means you rewrite it in terms of hyperbolic sine of y, and then differentiate and then use your use your identities to simplify, or you use the logarithmic differentiation, your answers are exactly the same. Right, then can look at hyperbolic cos. So this is the second one. If y is equal to hyperbolic cos inverse of x, we know that this means that hyperbolic cos of y is equal to x. Then we differentiate it the way we did the previous one. We have hyperbolic sine of y times y prime. This is equal to 1, and this means that y prime is equal to 1 over hyperbolic of y. Then we use our identity. This is 1 over the square root of cos squared minus 1. Okay, and then this y over here, we replace it with this value over here, because we want our final answer to be in terms of x. So this is 1 over square root of cos hyperbolic of hyperbolic inverse of x squared minus 1. So hyperbolic cos inverse. Those two cancel each other out, and you're left with the square root of x squared minus 1. Okay, so that is the derivative of a hyperbolic cos inverse. And the third one is when you have tan is so this is what we have, and then we would differentiate in the normal way. We have sec y prime, this is 1, so y prime, this is equal to 1 over sec hyperbolic squared. Okay, then remember that the hyperbolic sec squared is 1 minus tan squared. So this is 1 over 1 minus tan squared. Okay, and then we want our final answer to be in terms of x. So this y here, we replace it with the y that we have over there. So this is 1 over 1 minus tan hyperbolic of hyperbolic inverse, not y. Okay, so this is 1 over 1 minus x squared. Okay, so that is our derivative. Then the other three, you would do them in the same way. And as you know, most of the time we're not just interested in the derivatives of tan inverse of the function that we're differentiating over here is not just x, it's some other function of x. So it might be x squared or e to the power of x or something. So it's not just an x that we have here. So we want to know, how do we extend this so that it includes those functions? And with that, we have a table of derivatives. The first one is if we have y is equal to sine inverse of f of x, then the derivative, this is x over the square root of 1 plus, like that. So it's the same as with the arc functions. In the numerator, you have the derivative, and then under the square root, you square the function that you were differentiating. And the second one, if y is equal to hyperbolic cos inverse of f of x, then y prime, the derivative in the numerator, and in the denominator we have our function minus 1. And the third one, if y is hyperbolic tan inverse of f of x, then y prime, this is the derivative in the numerator, and then in the denominator we have 1 minus f of x squared. Now here there is a condition that the absolute value of f of x is less than 1. Otherwise, the derivative does not exist. Then number 4, if y is hyperbolic sec inverse of x, then y prime. In the numerator, we have negative f prime of x, f of x, square root of 1 minus f of x squared. So you can see they are pretty similar to the ones with octrix, except that the signs are different. Then number 5.
Go back, miss.
Is equal to inverse of f of x. So this means that y prime is equal to, those ones are negative. So if you remember, here, this is minus f prime of x over f of x square root f of x squared plus 1. And then the last one, if y is equal to cot inverse of f of x, then y prime is equal to f prime of x 1 minus f of x squared. And here the condition is that the absolute value of f of x must be greater than 1. So you can see this is similar to the one with tan, except that the condition is different.
Miss number 4, please.
Somebody's saying something? I can't hear
Number
you.
4. Number 4.
Who's that? Is that Mwene? Can you speak up, please? I can't hear you. What about number 4? Okay, you can type your question there and then we can sort it out. Okay, so we look at somebody saying something. Please get you close to your mic. Yeah?
Quickly go back to the previous page. I just want to copy something. Ma'am, can you hear me?
Yeah.
Why is number 4 not having f of x?
It should have an f of x.
Okay, just hold on. Let me copy. Okay.
Okay, so now we look at some examples of working out these derivatives that involve arc hyperbolic inverse functions, or arc hyperbolic functions. Okay, so for the first one, we have y is equal to hyperbolic sine inverse of x squared plus hyperbolic inverse of the square root of x. So here, what we do is we just use our table of derivatives. So you can see for the first one, we have hyperbolic sine of f of x. So the way to differentiate this is your f prime in the numerator, and then in the denominator, we have 1 plus f of x squared under a square root. And then the cos hyperbolic inverse will do it in the same way. So y prime, this is the derivative of this function in the numerator. The derivative of that is 2x. And then in the denominator, we have the function squared. So we have x squared squared, which is x to the power of 4 plus 1. And then the second one, we have the derivative in the numerator. So 1 over 2 square root of x. Then in the denominator, we have this function squared. So we say square root of x squared, which is just equal to x. And then minus 1. So you always want to simplify as far as possible, so it looks nice. Somebody saying something? Okay, so our y prime, this is equal to 2x over the square root of x to the power of 4 plus 1, then plus 1 over 2 square root of x squared minus x. Okay, so that you can write it like that, so it looks better. Number 2, we have y is equal to hyperbolic tan inverse of tan of x plus x hyperbolic tan inverse of x. Okay, so we want to differentiate this. We do it in the same way. So here, y prime. So the derivative of tan, we have the derivative of this function here in the numerator, and we know that the derivative of tan is sec squared. So we have sec squared in our numerator, and then in the denominator we have 1 minus the function squared. So this is 1 minus tan squared of x. And then for the second function, or the second term, we have to use the product rule. So we have hyperbolic tan inverse of x, and then we have x over 1 minus x squared. Shouldn't write it like that. This is a plus here. Just write it better. Okay, so use the product rule to differentiate this one over here. Okay, then if you can simplify it further, then you go ahead and do that, but I would just leave it like that. Number 3, Fy is equal to like inverse of e to the power of 2x. So differentiate this one, y prime, the derivative of sec here. On the numerator, we have the derivative of e to the power of 2x. So we have negative 2 e to the power of 2x. Then in the denominator, we have the function as it is, then the square root of 1 minus the function squared. So we have 1 minus e to the power of 4x. And this is just negative 2 over square root of 1 minus e to the power of 4x. So you can cancel the e to the power of x there and the e to the power of x in the denominator over there. Number 4, y is equal to x to the power of y is equal to x to the power of hyperbolic cot inverse of x squared. So this one, good candidate for logarithmic differentiation. So you take logs on both sides. So we have ln of y. This is equal to x squared ln of x, and then you differentiate this using the product rule. So we have y prime over y. This is the derivative of the first one is the derivative of x squared in the numerator, which is 2x, and then in the denominator we have 1 minus our function squared. So that's x to the power of 4. Then we multiply by the second one as it is, and then we have the first one as it is multiplied by the derivative of ln of x, which is just 1 over x. Okay, so there isn't anything that can cancel with what we have, so we just need to make y prime the subject. So y prime, this is y, 2x ln of x over 1 minus x to the power of 4 plus, we call inverse of x squared over x. Okay, and you can always rewrite this y like that. So this isn't a very long term. So on your paper it will fit nicely, but leaving it like that is also fine. And then number 5. We have y hyperbolic cosec inverse of x, y squared plus e to the power of xy. So here, implicit differentiation, but remember when you have x and y, you must use the product rule. So this one, we have to use the product rule. Over here, we will have to use the product rule. So we differentiate. For the first one, we have y prime cosec of x, y cosec inverse derivative of that is -1 over x squared plus 1. Okay, so that's just the left hand side. Then the right hand side, 2y prime, the derivative of y squared, and then the derivative of e to the power of x, that is e to the power of xy rather, multiplied by x y prime plus y. Okay, then the next part is just algebra, collecting the terms that have y prime. So we're looking at this one here, that one, and this one over here. So collect all the terms with y prime on one side and factorize. So y prime, so the first one is cosec inverse. The next one with y prime is 2y. So when it goes to the other side, it becomes negative. And then we have e to the power of xy times x. When it goes to the other side, it is negative. Okay, so that's your y prime, and then everything else goes to the other side. So the negative y over x, square root of x squared plus 1, when it goes to the other side, it becomes positive. This is x square root of x squared plus 1. And y e to the power of xy, it's already on the right hand side and it's positive. So I have y e to the power of xy. Right, then your y prime, divide by the bracket on both sides. So y prime, this is y over x squared plus 1, y e to the power of xy over hyperbolic x 2y x e to the power of xy. So again, you can combine the numerators so that you don't have a fraction in the denominator to make it look slightly better than it does now, but I would leave it like that. Okay, and then that brings us to exercise 1.5. So here we'll look at the even numbered questions. We start with y is equal to hyperbolic sec inverse of cos x. So we work out this derivative. So remember, this is our f of x. So y prime, this is negative f of x. So negative f prime of x. So we differentiate cos x. The answer is negative sine x. So we have negative sine x. That gives us positive sine x. And then we multiply f of x. So we have cos x. Then the square root of and this be f of x 1 minus f of x squared. So we have 1 minus f of x squared. This is 1 minus cos squared of x. Okay, and again, you can always use your identities. We know that 1 minus cos squared is sine squared, and the square root of that is sine. So this you can rewrite as 1 over cos x or sec x. Number 4, we have y is equal to hyperbolic tan inverse x squared minus 4 x squared plus 4. Okay, so the derivative in the numerator, we should have the derivative of this function over here, and the derivative of that we get it using the quotient rule. So that is the denominator as it is.
Previous page, ma'am.
Oh, it is saying half page, but let's make it one full page.
It's okay.
3 times the derivative of the numerator, which is 2x, minus the numerator as it is, derivative of the denominator over the denominator squared. And then in the denominator we have 1 plus our function squared. And that is 1 minus, sorry. Okay, so we can simplify as far as possible. Here in the numerator, you can see that 2x is common. Then we'll have x squared minus x squared, and then 4 minus negative 4 is 8. So we have 8 times 2x, so we have 16x. And then I have x squared plus 4 squared. And then 1 minus x squared minus 4 over x squared plus 4, the whole thing squared. Okay, so this one we can still work on it a little bit. You have 2 fractions here that are dividing. So we just have 16x, x squared plus 4 divided by, okay, so these two, first you combine them, you write it as x squared plus 4 squared minus x squared minus 4 squared over x squared plus 4 squared. Okay, and then the division changes to multiplication, and then you write the reciprocal of this function over here. So we have 16x over x squared plus 4 squared times, where's the people of the other one? Okay, and then over here, you can multiply this out and simplify, or you can factorize it using the difference of squares. So you'll have x squared plus 4 minus x squared plus 4. That will give us 8. Let's do it here. So this part here, we have x squared plus 4 minus x squared plus 4, and then x squared plus 4 plus x squared minus 4. Okay, those two will cancel. So in the first bracket, I have 8. And then in the second one, I have 2x squared. Okay, so this is just 16x squared. Okay, so you can see those two cancel. And then I have 1 over x as my final answer. Okay, so that's just algebra, simplifying as far as possible. Okay, so we'll stop here for today and continue on Friday. Friday, our class is at 9:30.
Hello.
Is somebody saying something?
Yes.
Echo, but I can't hear what you're saying. Johannes,
Yes.
you need to speak up or get closer to your mic.
Okay. What I wanted to ask is, ma'am, can you please share with us a prescribed
Share what?
textbook, a prescribed textbook other than the technical on MS Teams?
Which
If you have
prescribed textbook is that?
anyone, if you have.
I just have the Technicon book. The other ones I have are hard copies, so I wouldn't be able to share that on Teams, unfortunately. But if somebody in the class has it, you can share it. I don't have a copy of it, sorry. Okay, so enjoy the break tomorrow, and we meet again on Friday. Or does somebody have a question? Okay.